dependent upon?
Temperature, concentration, particle size.
Right. Right. Now we'll see in detail. Okay. Can you see my screen now?
Yeah.
Okay. So let's get started. The rates of reaction. Okay. Basics are same. Now, it is dependent upon the particles and collisions, the temperature, the concentration and pressure, the surface area and catalyst, and the summary activities that we'll take at last, we'll discuss, fine? Okay, so what does the rate of reaction mean? The speed of the reaction, different chemical reactions are going to hugely be different. There will be different rates, whether slow, whether medium, whether very fast reaction. Okay, so the speed of the reaction is called as the rate of the reaction. Okay, so roasting is a slow process. You must have seen. A baking process is slightly in between, and explosion is very fast. Right? It's very instantaneous. Right? So these are few reaction types. Now, why are some reactions faster than other? Let's see, because there's a collision between them that will be stronger. Okay. So the reaction take place when the particles collide with a certain amount of energy, and the minimum energy which is required needed for the particles to react is referred to as the activation energy and is different for each and every reaction. So one reaction can require this much activation energy, whereas another reaction might require this much huge amount of energy, right? So they are temperature dependent, right? And various reactions are going to require different activation energies. Okay. What frequency of collision? How frequently two molecules are getting collided? Okay, if they are taking 10 hours, means it is a very slow process. If it's just taking one minute second, it will be very fast reaction, right? Example I'm giving. Now the energy that these two particles or particles when they're colliding up is producing, say, 10 joules. Whereas two particles for a nuclear reactor, for example, the particles of a nuclear reactor, they are producing this much kilojoules of energy, right? So it's also dependent upon the energy. Are the reaction going to emit a lot of energy when the two particles are colliding? So if that is happening, a faster reaction will result in, right? Clear? Any doubt? Okay, you can just go through this slide now. Any doubt? Okay, let's move to the next slide now. So anything that increases the speed number of successful collisions, there should be successful collisions means they should actually give some product. It is not that collisions are happening and they are not making any changes. There should be successful collisions. One is increased temperature for a faster reaction. You require increased concentration of dissolved reactants, and you require increased pressure also, right? Increased surface area of solid reactant. So if the question comes indirectly, you have to put the factors which are responsible for a faster reaction. Suppose they give you say zinc plus HCl, and they ask you that a certain girl was conducting an experiment, and you have to and it was originally taking 10 hours. Now you have to complete the reaction in 1 hour. So one thing that you could do is you can increase the temperature, or you can increase the concentration, or you can increase the pressure of the gaseous components, or you can increase the surface area in which this particular reaction is taking place, right? Use of a catalyst, one of the best factors that is dependent. So you can add a particular catalyst that is going to support this reaction. Not every catalyst is going to give you the same product. Some catalysts might not even show their presence in a particular, on they're not going to speed up in certain reactions. So that's temperature dependent and reaction dependent also, right? Okay, so if the collisions are more, there will be faster reaction, right? Okay.
Yeah.
Here only they were all very far away. No collision was taking place. Here one collision, here two collisions, here three collisions, and here all are getting collided. So it is going to give a very, very fast reaction. Okay, clear? Next. Wait. Next is this part. Can you see? How can the rate of the reaction be measured? Suppose you have magnesium that we have already taken the example of, right?
Yeah.
Magnesium plus hydrochloric acid to give magnesium chloride plus H2. We have just discussed the amount that gets used up. We can calculate centimeter cube per minute, whatever the quantity of the amount that you're getting per 1 minute. Okay. Okay. Just go through this part. If you want to write anything, you can write, like make your own notes. Okay. Done. Okay, you can write it down if you want to write. I can wait. Okay, no need to hurry up and nothing. Okay, let's move to the next slide now. So setting up the rate experiments, this we have already just seen in the PDF that there was a conical flask, there was a rubber connector. When you were, this was a gas syringe. Okay, so the here you were controlling it, and you are reacting magnesium and HCl to it. Certain gas will be liberated out. Now, this will give H2 plus MgCl2. Now, we are interested in finding out what amount of gas it is going to release, right? So that amount would actually decide whether the reaction, if the amount would have been greater, means the reaction would have taken at a much faster pace, right? So this is the rate of the reaction that we have just studied from the graph also. Here the reaction has actually stopped. Okay, it's parallel to x-axis. Here, initially it is very, very fast, and then it has actually, the slope has come down. Means the reaction has become a little bit slow. Okay.
Okay.
Okay, you can find out the coordinates. For example, here is 45 and here is 20. That will give you the rate of the reaction. Okay, so the rate of the reaction is whatever the gas has been produced upon the time that it has taken. Clear?
Okay.
Any other doubt? Okay. Next. Next comes temperature. So more the collisions, more will be the reaction that will be faster. So the higher the temperature, faster will be the rate of the reaction. Generally, what is being seen is, it's generally okay. Generally, whatever is seen is that if you have a particular reaction, if you increase the temperature of that particular reaction by 10 degrees Celsius, okay, temperature difference only. Suppose initially it was 30 degrees Celsius, now you are taking it at 40 degrees Celsius. So the generally the rate of the reaction it becomes double. This has been witnessed. Okay, clear? So if earlier it was 100 degrees Celsius, now the reaction is taking place at 200 degrees Celsius. We assume that we generally see that in many of the cases that the rate initially, if it was 2, here now it would have been 4, doubled. Okay, rate would have been doubled. Okay, clear?
Yeah.
So at higher temperature, the particles have more energy. This would mean that they are going to move very fast and they will have more likely energy to have that frequency of collisions that would be more, and the energy that they would be imparting will also be more. Clear? Next. When the particles collide, they do so with more energy and do so, there will be a number of successful collision that is going to increase. Okay. Why are batteries likely to run down more quickly in cold weather? Do you know this reason?
Yeah, because I think due to the cold weather, the temperature is really low. So the reaction that will happen, that's what they do.
Right, absolutely. So the reaction is very slow, or there is no change in the reaction, and very low temperature means inadequate amount of collisions, inadequate number of successful collisions. So thus, you can see that there is a rundown more quickly. So clear? Any problem till here? Okay, let's move to the next part now. The reaction between sodium thiosulfate and HCl, it is going to produce sulfur. Can you see here? Just an example. You don't have to remember, just an example for your understanding. This is another reaction. Now, sulfur is actually a solid. It would turn the solution cloudy. Clear? How can this fact be used to measure the effect of temperature on the rate of a reaction? You can do that. Next is concentration and the pressure. So, more the concentration, more will be the higher will be the rate of the reaction, right? You can just go through the slide. ज्वाइन कर लेती हूँ अगर मैं नहीं करूँगी। Any problem till here? So at higher concentration, there will be more particles in the same amount of space. You can see same area you have, but the particle is more. So they are going to often collide with more uh, in lesser time. They will have also they'll have more collision propensity, right? They'll collide more often. Any problem till here? Can I move to the next slide? Why does increasing the pressure of gaseous reactants increase the rate of the reaction? So as the pressure is going to increase, the space in which the gas particles are moving, they will become smaller, right? And the gas particles would come together and they will increase in, because now you have less higher pressure. So they are going to come very close to each other and they will collide with more energy, right? Okay, next part. Surface area and catalysts. So you already know what is the surface area, where you increase the surface area. So increasing the area would mean the reactants are going to have more space to react, right? Clear? The next part we will follow up. Marble chips are made up of calcium carbonate. They react with HCl to produce carbon dioxide. Can you see the reaction? Here, there could be a difference. You already know if you take it in a powdered form, it will be more better. More the surface area, more will be the rate of the reaction. Clear? What are catalyst substances that change the rate of the reaction without getting being used up in the reaction? Okay, so EA is the activation energy. Okay, and what is the role of catalyst? They are going to decrease, lower down the reaction's activation energy, which is represented by EA. Clear? Any doubt here? Sure. So EA without catalysts is high. EA with catalyst, it has come down, right? Activation energy now is lower. Clear? Next. Everyday catalysts. These are some of the examples of the catalysts that you have. Can you see on my screen? Okay, what you can do is, I'm going to put this as on a whiteboard. I'm giving you some notes on the whiteboard that you can write it down. Okay, just give me 1 minute. Fine. Those notes you can copy in your copy. Okay, just wait.